Today we're doing lesson 8.8, find solutions of inequalities. So before we start this, there's 6 different symbols that you have to know what they mean. So let's write them over here. We have this symbol, which means what?
Less than.
Less than. It kind of looks like an L, so it means less than. And then if we add a part of an equal sign underneath that, it means less than or equal to, not and, or. So less than or equal. That's not very good, equal. Or equal to. Then we have greater than. Greater than or equal to. This, of course, means equal. This means not equal. Okay. Yes. Thank you. I appreciate that. Tony, put your put a tally mark down. Okay. Solutions of inequalities. How do you determine whether a number is a solution of an inequality? An inequality is a mathematical sentence that compares two expressions using the symbols less than, greater than, less than or equal to, greater than or equal to, or not equal. These are examples of inequalities. So 8 is less than 11. 9 is greater than -4. Then we have a variable here that says A is less than or equal to 50, and X is greater than or equal to 3 2/10. On the A is less than or equal to 50. A is less than or equal to 50. Says a solution of an inequality is a value of a variable that makes the inequality true. Here's the important point. Inequalities can have more than one solution. So one solution to this would be 50. Is 50 less than or equal to 50?
Yep.
Yes. We could also make that, instead of 50, we could make it 9, -9, anything that's less than 50, right? But would be a solution, or less than or equal to. But like 60 would not be a solution. You with me? Okay. Basically what we're doing today is we're taking inequalities with variables in them, and we're plugging in numbers for the inequalities and seeing whether it makes it a true statement or not. Okay? A library has books from the Middle Ages. The books are more than 650 years old. More than is like greater than. 650 years old. The inequality A is greater than 650, represents the possible ages, A, in years of the books. Determine whether A equals 678 or A equals 634 is a solution of the inequality, and then tell what the solution means. So first we're going to plug in for A, 678. Is 678 greater than 650?
Yes.
Yes. Okay, so that means 678 is a solution. What about this? 634, is that greater than 650?
No.
No, so that means 634 is not a solution. Okay, tough stuff, right? Do you see how they put this little question mark above this? That's the moment that you check and see whether it's true or not. So we'll start with 678. It says substitute 678 for the A. So 678 is greater than 650. That's true. 678 is greater than 650. The inequality is true when 678, when A equals 678. So 678 is a solution. Now we're going to check and see if 634 is a solution. We figured out that, so it says, here's the inequality. We're going to substitute 634 for the A and then check. Is 634 greater than 650? No. 634 is not greater than 650. The inequality is not true when A equals 634. So A equals 634 is not a solution. Okay, so the solution A equals 678 that we found out worked means that a book in the library from the Middle Ages could be 678 years old. Okay?
But like 60, so we're trying to work on a different
Okay. All right, next page. Determine whether the given value of the variable is a solution. So here's our equation. B is less than 3/10. B is less than 3/10. And they want us to plug in -2/10 for B. So I'm going to cross that out and write -2/10. Is -2/10 less than +3/10? Yes. So I'm going to plug in here -2/10. And that question mark indicates we're checking it. And -2/10 is less than 3/10. The inequality is true when B equals -2/10. So B equals -2/10 is a solution. Okay, so when we're dealing with whole numbers like 50, super easy to tell whether, 60 is bigger, 40 is bigger. It gets a little more challenging when we're dealing with fractions, but we're still doing what we've done before, comparing two fractions to see which one's bigger. And that's why I have these little visuals out here to help us. So the next one, the inequality is M is greater than or equal to 2/3. And we're going to plug in for M 3/5. So now we have to figure out if 3/5 size parts is greater than or equal to 2/3 size parts. Sometimes it's hard to tell, but if you look at the amount that's missing, this amount that's missing is bigger than this amount that's missing. So this would be a smaller fraction than this. So this would not be true, correct? Because 3/5 is not bigger than 2/3. Sometimes it's hard to tell too, so you can actually, do you remember the strategy I've given you before to compare two fractions and see which one is bigger, Briley?
Common denominators.
You can do common denominators. There's one other thing, Ryan.
Cross multiply.
Cross multiplying, okay? So both of you put yourself down for a point. I prefer cross multiplying because I think it's easier. So we're comparing these two fractions, right? So if you go up, 5 times 2 is 10, and then 3 times 3 is 9. Since 9 is less than 10, 3/5 is less than 2/3. So to make this true, we'd have to have a less than or equal to sign. We don't, so that means this is not a solution, okay? So 3/5 is less than or greater than or equal to 2/3. They went ahead and did common denominators. Do you remember when I told you guys to find common denominators? You can multiply each fraction by the other fraction's denominator. Here's an example, 3/5 and 2/3. We multiply by the other fraction's denominator. So we're going to multiply 3/5 times 3/3 and get 9/15. We're going to multiply 2/3 by 5/5, and that gets us 10/15. Notice the numerator is the same numerators that we're comparing over here, because cross multiplying is a shortcut to finding common denominators. You just don't have to find the denominator part, because when the denominators are the same, we're just looking at the numerator anyway. Here we're just looking at the numerator. So since 9/15, or now we're comparing 9/15 to 10/15, since we found the common denominator. 9/15 is not greater than 10/15. The inequality is not true when m equals 3/5. So m equals 3/5 is not a solution. Okay. Example 2, an airplane can hold no more than 416 people. That's the max. Can it hold 416?
Yep.
Can it hold 500?
No.
No. Can it hold 2?
Yes.
Yes.
This
Okay.
is the pirates.
Yes, so here's the inequality we're using. P is less than or equal to 416. Says the inequality represents the possible number of passengers P on the airplane, where P is a whole number, because we can't have half a person. Okay? Somebody in the last class said
What if they don't have
baby
legs?
is still a whole person,
Well,
right?
Not
But
technically.
anyway,
have
okay,
legs.
somebody in the other class was like, what about a baby? I'm like, that's still a person.
Oh,
Okay,
thing.
all right, but anyway, give 2 solutions of the inequality and tell what the solutions mean. The solutions of the inequality are whole numbers less than or equal to 416. Less than or equal to 416. 200 is a solution because 200 is less than 416. Somebody else give me a solution that will work. Chase?
1.
1. P equals 1 is a solution because 1 is less than 416. The solution that we came up with means that the number of passengers on the plane could be 1 or 200. Either one would work. Okay, now we're going to get into what I'm going to want to see as you do these problems, okay? How you're going to show your work. I do want to remind you that when you're comparing 2 negative numbers, such as -2 and -3, which one is bigger?
-2.
-2. Because remember, numbers always get bigger as they move to the right, okay? So sometimes you have to think of them on a number line and say, okay, which, -3 is more, excuse me, more negative than -2, so it's smaller. Yes.
Can you please send
Owen and Chase to the office, please?
We're in the middle of a lesson. Can it wait, or do you need them now?
Oh, it's fine. If you want to send them when you're done, that's fine.
Thank you.
Thank you.
Okay. So the next thing that I want to remind you of is if you have a fraction and you're comparing that to a decimal, can you turn this fraction into a decimal? How do you do that? Briley? Divide the numerator by the denominator on your calculator. Okay, so here we go. A is greater than or equal to -6. A is greater than or equal to -6. They want us to replace A with -3. The question mark above that indicates we're thinking, is -3 greater than -6?
Yes.
Yes, because it's further to the right. So this is what you're going to write as your answer. -3 is a solution. Okay, the next one says y is less than 7 8/10. Y is less than 7 8/10. We're going to replace the y with an 8. Is 8 less than 7 8/10? No. So here's what you're going to do. 8 is less than 7 8/10, and we're going to put a question mark above that because we're checking. 8 is not a solution. Okay, so you're just going to plug in the number for the variable, the value they're giving you, and then write a question mark above the symbol so you can say, I'm looking at it, I'm thinking it through, and then put whether it is or is not a solution. Okay, the next one, C is greater than 1/4. We're going to replace C with 1/5, and then we're going to write the rest of the inequality with a question mark. 1/4, they're saying 1/5 is greater than 1/4. Is that true?
Yeah.
No.
Oh,
They're
no.
saying 1/5 is greater than 1/4. That is not true. So 1/5 is not a solution.
I cross multiplied them and there was a 4 on this side and a 5 on this side, so.
With these, when you have numerators that are the same, 1/5 and 1/4, normally you think 5 is bigger than 4, right? But when you're talking, when they're on the bottom of a fraction, the bigger the number, the smaller it is when the numerators are the same, okay? It's just like negative numbers. If you're comparing -3 and -6, the bigger the number, the smaller it is. So negatives and fractions work that same way as far as it's kind of the opposite of what it is as whole numbers. Okay, next we're going to plug in 3 is less than or equal to 3. Write a question mark to check it. Is 3 equal to 3?
Yes.
Yes. So 3 is a solution. Okay, next we're going to plug in -51 hundredths for D is less than -52 hundredths. Now normally if these were positive numbers, you would think 52 hundredths is going to be bigger than 51 hundredths, right? But since they're negatives, it's the opposite. -52 is going to be further to the negative side than -51. So -51 hundredths is not a solution. Okay, then we're gonna put, oh, I forgot my question mark up here. And then I'm gonna plug in 3/4 for T is greater than or equal to 2/3. one way that you can do this, you can use your, 2/3 and 3/4. And they are saying that they're saying 3/4 is greater than or equal to 2/3. Is this bigger than this?
Yes.
Yes. So 3/4 would be a solution. 3/4 is a solution. You can also rewrite them as decimals. 3/4 is the same as 0.75. 2/3 is the same as 0.66, which go repeating. So 0.75 is greater than 0.66. So yes, it would be a solution. That's another option you can go about solving. Okay, we're gonna do this part together, and then you guys are gonna try some. Okay, so it says determine whether s equals 3/5, s equals 0, or s equals 1 and 75/100 are solutions of the inequality. Our first inequality is s is greater than -1. I'm gonna write that 3 times because they are giving us 3 numbers to check. First one we're gonna check is 3/5. Is positive 3/5 greater than -1?
Yes.
Yes, all positive numbers are greater than negative numbers. Is 0 greater than -1?
Yes.
Yes, because it's further to the right. And then 1 and 75/100 positive, is that greater than -1?
Yes.
Yes. So here's how you're gonna write this. S equals 3/5, write this down. S equals 0 and S equals 1.75 are all solutions. Okay. Next, we're gonna plug in for the S in this equation. S is less than or equal to 1 and 2/3. S is less than or equal to 1 and 2/3. S is less than or equal to 1 and 2/3. First, I'm gonna plug in 3/5. Is 3/5 less than 1 whole? Is 3/5 less than 1 and 2/3?
Yes.
Yes. Okay. Is 0 less than 1 and 2/3?
Yes.
Yes. Is 1.75 less than 1 and 2/3?
No.
Which is like 1.66.
No.
No. So, solution, solution, not a solution. So, S equals 3/5. S equals 0 are solutions. S equals 1.7. S does not equal 1.75. So we can write it like that. Our solution. Okay, last one of these. S is less than 43/100. S is less than 43/100. S is less than 43/100. We're gonna put in 3/5. 3/5. Go ahead and on your calculator do 3 divided by 5. 0.6. Since this has 2 decimal places, I need to add a second one. Is 60/100 less than 43/100?
No.
No. 60 is not less than 43. Okay. Is 0 less than 43/100?
Yes.
Yes. Is 1 and 75/100 less than 43/100? Avery, is 1.75 less than 0.43? No. So 0 is the only solution. S equals 0. S does not equal 3/5. S does not equal 1.75. Okay. Let me see where we're at in the video. Give two solutions for the inequality. I'm going to pull sticks. You're going to give me a number that is a solution. Avery, give me one solution that would make this true. E is a number less than 3. Give me a number less than 3. 2. So E equals 2. That is a solution. Give me another solution that would, or give me another solution that would make this true, Peyton. 1 is a solution. E equals 1. Okay. Next we have P is greater than negative 12. P is greater than negative 12, so we're looking for two numbers that are greater than negative 12. Wyatt Payne.
Positive 12.
Positive 12 is negative, or is greater than negative 12. Good. And Katana, give me another one. Greater than, positive 2 is greater than negative 12. So P equals positive 12, or P could equal 2. Good. Okay. Then we have Y is greater than or equal to 5.8, or 5 8/10. Okay. Y M, give me a number that would work for Y that's greater than 5.8.
6.
6 would work. Luke, give me another one.
4.5.
4.5 is not greater than 5.8.
Oh, what do we? Where was it there? Okay. 5.8.
5.8 would work because 5.8 is equal to 5.8. So either one of those would work. Y could equal 6. That's what Y is. And then Y could equal 5.8. Okay. Our last problem, a person must be at least 18 years old to vote. The inequality A for age is greater than or equal to 18. Represents the possible ages A in years at which a person can vote. Determine whether A equals 18, A equals 17 and a half, and A equals 91.5 are solutions of the inequality, and tell what this solution means. Would 18 work?
Yes.
Yes. Would 17 and a half work?
No.
Would 91.5 work?
Yes.
Yes. So and what that solution means is a person who is 18 or 91 and a half can vote. A person who is 17 and a half can't vote. Your assignment's going to be the even problems on the last page.